All right, 4.1. The notes for 4.1 are here. The notes for 4.2 are here. None of this is new to you. This should all be reviewed. Okay? We talked about this in chapter 1, chapter 2. And what it is translations. Translations, that's just when we move something. Remember? So we grab something, we move it left, or we move it down, or we move it up, left, right, up, down. Okay? By adding to the x or by adding to the y, which also means subtracting. Okay? Reflection. Reflections, remember those were just, hey, if I have this shape right here, it's going to reflect across here and go like that. Okay? That's it. It's reflecting. Now this one reflects against the x-axis, right? So that means that it would be this guy. So the y's become negative. That's it. That's it. Okay? So the y's, the x is the same, but the y became negative. That's it. We talked about this. We didn't do a formula, but we talked about it so that you knew what reflection would look like, right? And that's different from rotation. If I'm going to rotate this thing, right, it's going to look a little bit different. Does that make sense? It was rotating. Now that is a counterclockwise rotation, right? So a counterclockwise rotation would be this one. That means the y becomes the x. And it becomes negative. The x becomes the y. That's it. So they rotate. The cool thing you're going to be able to notice is when you see this x and y flip, when it rotates, you're going to know, oh, rotation. Okay? Then you just have to figure out which way did it rotate. Did it rotate clockwise or counterclockwise? Does that make sense? So, if it just becomes negative, reflection. But only one of them becomes negative. Notice how this one, both of them become negative? Because what happened was they rotated, right? Boom, and then they rotated again. Boom. And what that is a 180-degree rotation. Okay? So, that's the difference between reflection and 180-degree rotation. Now think of this. What if I reflect it this way and then I reflect it that way? So what if I reflect this here and then I reflect it here? Right? So it would look like this. Right? And that would be either two steps, reflection, reflection, or 180-degree rotation. See how that is? So those would be the same thing. A double reflection, meaning an x-axis reflection and a y-axis reflection, or 180-degree rotation. Okay? So you're going to have to know that for that state test. Okay? Next. Dilation. Dilation's easy because it just takes this thing and makes it bigger. Or smaller. Oops, won't put an extra side on it, but right. So it either makes it bigger or smaller. Okay, and the way it happens is by multiplying. Obviously, to make it bigger, multiplying by a number bigger than 1. To make it smaller, multiplying by a number smaller than 1. Or some people like to call that division, right? Okay, but I like to just call it multiplication. That way, everything's simple. It's always the same thing. Just like adding a negative is the same as, it's just adding. It's not subtraction. It's adding a negative. So keep it simple. If you're adding, translation. If you're making something the opposite, rotation or reflection. The opposite. Like when you're looking in the mirror, it's the opposite view. Okay? Rotation. That's when the x and y's flip. Okay? Dilation. So when things get bigger or smaller. Okay? And then some of the other things you've learned since 3rd grade. Okay? Acute triangles. An acute triangle is 3 angles in the triangle are all less than 90 degrees. They're all acute. They're all smaller than 90. An obtuse triangle, one angle is greater than 90. Okay? So it's 110, 120, whatever. Okay, so obtuse, right? So you have an obtuse angle, that's an obtuse triangle. Acute, okay? Then you have, of course, right. Right just means 90 degrees. Okay? Where do we go from there? Okay, equal angular. Okay, this is one name for it. It's also called equilateral. Okay? The reason is, if all the angles are the same, then all the sides are the same. So we call those two different things, equal angular or equilateral. Okay? But it's the same thing. Okay? It's a triangle that has all the same sides, or it's a triangle that has all the same angles. Okay? So if a triangle has to have 180 degrees, what are these angles? Guys, think about it. If a triangle has to be 180 degrees, what are each of the angles? How many times does 3 go into 180? 60.
Yeah.
60. Okay? So you have 3 60-degree angles. Okay? Isosceles. Iso, 2. That means 2 sides are the same or 2 angles are the same. The sides opposite of the angles are the same. That's all. We've learned this. Okay? Scalene. No sides are the same. That means no angles are the same. Okay? This is the easy part. Those are the notes. So I'm going to label this as MTS Geo Chapter 4 notes. Okay?
Did you see Allie's story?
All right.